So I welcome everyone to this session, video session. So in this session, we are going to discuss the topic of N-gram language model. Okay. So first we will see the session objective of this particular video session. The first session objective is to understand the role of language model. Especially, we are going to discuss about the N-gram model and also how we can find the occurrence of the sentence or words or characters, how we can estimate using maximum likelihood estimation. This is the first objective we are going to see in this particular session. Next one, while we using the N-gram model, there are few drawbacks or there are few challenges. So how we can able to overcome that challenges using smoothing approaches. So this is what the next objective we are going to discuss in this particular session. So once again I will repeat. So in this particular session we are mainly focusing on two session objectives. So one is to understand the role of language models. Especially we are going to talk about the N-gram model and how we can estimate the occurrence of the sentence or word by using maximum likelihood. And then second objective is, so what are all the challenges while we are incorporating N-gram model, how we are able to overcome it using the smoothing concept. Especially we are going to talk about the Laplace smoothing. So these are all the main topics we are going to discuss in this particular session. So first we are going to start with the introduction to N-gram model. So what is N-gram model and why we are going for N-gram model, where we are using this N-gram model. Okay, so then what are all the various categories of N-gram model practically people are using, and then we are going to see some practical problems. Through that we can able to understand the concept very clear. Then after that, as I already explained, so what are all the challenges while we are implementing the particular language model, how we are able to overcome the challenges using the smoothing approaches. So finally we are going to see one concept called perplexity. So in the language model, what is the impact of this perplexity? So this is what we are going to discuss in this particular session. So first of all, so last session we have discussed about bag of words, TF, IDF, all these concepts. Okay, so for what purpose we have used, we very well discussed. Okay, so in this case, so today we are going to discuss specifically talk about the language model. So why we are need a language model? First of all, everybody knows. Okay, so whether it is your natural language or whether it is a communication language or any other language, standard language if you take. Okay, sentence, if you take any sentence, it consists of some sequence of words. So why we are using that all the words and the vocabularies, everything for a communication or sharing a information. This everybody knows, right? Okay, sentence consists of some sequence of words. Okay, now to find the probability of statement or word or character, okay, so we need some language model. Okay, anyhow we will see it very detailed so that you will understand better. First try to understand it. Okay, in order to find the number of occurrence or the major occurrence of the particular word in that particular sentence. Okay, so in that situation, okay, so language model is expected. Okay, For example, so I am talking, okay, I am talking with my friend. So I know what are all the words I have to use based on the context. Okay, so everything I know. Suppose if I am talking with one one senior officer, okay, so I am very carefully use my words. Okay, so which word I have to use. Okay, so everything I know. Okay, so in the same way, okay, for example, nowadays in the digital world, okay, so robo is also practicing the same like human being. Okay, so how robo will understand the context, everything. Okay, so with whom the robo is talking. Okay, so what are all the words it has to use. Okay, because English, different words will convey the same meaning. Okay, but sometimes it will give it in the negative way. Okay, so we have to see the context. Okay, in that case, okay, to find the probability of the statement or word or character in the occurrence, okay, we need the language models. Okay, so in the language models, n-gram is one of the very basic concepts used in natural language processing to for getting that particular occurrence of words or characters in that particular sentences. Okay, I hope you understand what is language model. Okay, so actually sentence consists of several words. Okay, sequence of words, we are calling it as a one sentence. Okay, when number of sentences are together, we are calling it as a paragraph, and it will go on. Okay, so why we are in need of language models? To find the probability of statement. Okay, so that's what I told. Today we are in the era of industry 5.0 revolution. Okay, so robo is going to do the role of human being. So it is going to interact with the human being, or otherwise bot is going to interact with human being. So what is the words it is using for conversation? Okay, which kind of words it can use? How it can identify using the appropriate use of language models. Okay, so I hope you understand. So here in our context, we are going to discuss about n-gram model, which is one of the very popular and very basic model to deal with the natural language processing. Okay, so now, so where we are using this language or n-gram models. Okay, so this is one of the main question. For everybody it used to come, right? Because we are learning some concepts. First of all, we try to understand what is that concept, and then very important thing, why we are using that concept or why we are learning that concept, that we must know very well. Okay, now we will see few applications, major applications. There are n number of applications we can use n-gram model. So I am going to highlight very few major applications where these kind of n-gram or language models are very high essential or very high in needed. Okay, so first of all, context sensitive spelling correction. Okay, so in application like context sensitive spelling correction. What it means? Context sensitive spelling correction. What it means? I will give one sentence. Okay, so my office is about 5 minutes distance from my home. Okay, so this is the sentence. Okay, the office, sorry, is about 5 minutes distance from home. Okay, so this is the sentence. By mistake, instead of the word minutes, okay, it is wrongly printed, or it is wrongly given as minutes. Okay, now this is the sentence given to someone. Okay, the office is about, so 5 minutes distance from home. Okay, so this word is also have some specific meaning. Okay, so these type of situations sometimes we will get confused. Okay, so whether it is correct or wrong. Okay, so in that case, okay, I need some language model to interpret. Okay, so in such situations, okay, there are possibility for two words can occur in that particular place. So in that case, so I need an interpretation of an appropriate language model to say the probability of occurrence of minutes, the word minutes is greater than the probability of occurrence of the word minutes in this particular sentence. So this is the role of the language model. Okay, so that's why we are learning the particular language model, that is Ngram language model. Okay, so I hope you understand. So one of the application is context sensitive spelling correction. Okay, so we can say several examples. Okay, sometimes, okay, so we will say, okay, so wrongly mention dear sir instead of dear sir, right? Okay, okay, so in that case, the language model, so try to understand the context specific, and it will give the probability of occurrence of particular word will be higher than that particular normal word. So this interpretation is very much required while we are going for number of applications. Okay, so this is one of the application. So one application is context sensitive spelling correction. So in that case, so the interpretation of language model is essential. Second, very important one is speech recognition. Second, very important one is speech recognition. Actually, nowadays everybody is experiencing this one. So we are also talking with bot. Bot is giving reply. Okay, some speech to text conversion is happening. Okay, and also our speech is also, so bot or smartphones, it is able to recognizing. Okay, sometimes. Okay, so sorry. So I am saying that I am eating. Okay, so since the smartphone is recognizing, okay, so sometimes there may be a chance, maybe because of my accent, okay, so it will recognize us. Okay, so you might experience, right? Sometimes we used to talk with Google Assistant, right? Okay, sometimes it will take it in a different words, right? I hope most of you experience this one. Okay, so this is called speech recognition. So in that case, okay, this is what expected. Okay, so here I need an interpreter to say to the system that, so this is the most expected one rather than this one. That means the probability of occurrence of this word or this sentence is more than the probability of occurrence of this particular sentence. Okay, for this particular analyzing, okay, so we need a language model. Okay, so we can able to say several things, right? So we can say I saw a van. So there are several examples we can give. I saw a van. So sometimes if we talk with a smartphone with Google Assistant, okay, it will take in us eyes of an. Sometimes it will take in different way, but there is no meaning. The entire meaning is going in different way, right? So in that case, okay, the language model, okay, has to predict, okay, so which is the most probable occurring sentence or words, and it will highlight that particular one, okay, so that it will go for the particular same case. Okay, I hope you understand. Second very important application where we are using the language model is the speech recognition. So why I am again highlighting means because nowadays there are lot of projects, researches are going on in this speech recognition. Okay. Third one. So third one is machine translation. So third one is machine translation. I hope, I am sure everybody tried this one, machine translation, Google Translate, everybody tried, right? Suppose for example, okay, so in Hindi, Bada Boy is there, okay. So I am not that much good in Hindi for assumption, okay. So I want to translate this particular word to English so that I can able to understand the meaning of this, okay. So English, okay, sometimes it will give big brother, okay, sometimes it will give large brother, okay. If you take both the words big, large, both the synonyms are same, okay, but when you check most probably occurrence, okay, this one is the correct one when you talk with the standardized format, okay. So for understanding the context, okay, so which word has to suit for that particular case, based on that we need an interpretation of an efficient language model, okay. So these are all the places where the language model uh, need is essential, okay. So I hope you understand, okay. The third one is machine translation. Similarly it will go on, okay. So I can write natural language generation, I can say natural language generation, I can say sentence prediction. So we all experience this one, right? So while we are typing some sentence in our Gmail, okay, so it is giving some predicting and it is giving the sentence, right? Okay, so how it is doing? So all these things based on these concepts, okay, using the appropriate use of language model, okay, the system is able to predict the word correctly and they are helping us in completing that sentence in a proper way. Okay, so these are all cases. Sentence prediction or completion. Okay, so apart from that, there are several applications are there. Okay, so these are all some very popular and very common applications where we are using the language model. Okay, so first one is the context sensitive spelling correction. Second one is speech recognition. Third one is machine translation. Fourth one, natural language generation. And fifth one, sentence prediction or completion prediction. Okay, so whatever way we can pronounce it. Okay. Now I hope you understand the basic why what is mean by language model, why we are going for using the language model in this system. Once again I repeat, okay, to find the probability of statement, word and character or character, there is a need of language model. It is very, very essential. Okay. So in our context, we are going to see the very popular and basic concept, that is N-gram model in natural language processing. Okay. There are several applications where language model uh, impact is essential. Okay, so few we have already discussed: context sensitive spelling correction, speech recognition, machine translation, natural language generation, and sentence prediction and completion. Okay. Now we can move on to the next topic. Okay. So first we have discussed about, so what is language model? Now we are going to discuss about what is N-gram model. Okay. So as we already told, so why we are using language model? Now we are going to discuss about the N-gram model. Okay. An N-gram is a contiguous sequence of N items from the given sample of text or speech. Okay. So this N-gram model, okay, have several types. Okay. Starting from unigram model. Okay. So then bigram model. We will see everything one by one in detail. Okay. So that you will understand better. Okay. Okay. Yeah. So we have discussed about, so why language models are used, okay, and what are all the major applications where we use these kind of N-gram models. Okay. So the items can be phonemes, syllables, letters, words, or base pairs according to the application. So based on which application we are going to use this N-gram model. Okay, so the N-gram is a contiguous sequence of N items from a given sample of text or speech. Okay, so there are two categories, given sample of text or speech. So for our basic understanding purpose, so we are taking the text example. Okay. Okay, so here it is mentioned very clearly. The N-grams typically are collected from a text or speech corpus. Okay, so here, so now the question will come to everyone, right? So how how language model is going to predict the correct word, the suitable word to that particular sentence? As I already told, right, there are some 5 applications we have discussed, right? Okay, so in all the 5 applications, the necessity of language model or N-gram model is essential to identify which is the correct word or which is the correct spelling. To understand that, to analyze that, N-gram model is essential. Okay, so now the next question comes, how N-gram model will do that particular process? Okay. So how it will work? Okay, so N-gram model will use the concept of conditional probability. I hope you remember this term while we are learning mathematics or while you are learning artificial intelligence basic algorithm concepts, right? Sorry. Okay. So what is conditional probability? The probability of occurrence of B if A is given is equal to joint probability of A and B together divided by probability of occurrence of the word A. So once again I will repeat. So how N-gram model is able to analyze or is able to predict the word occurrence suitable for that particular sentence? How it is doing? Using the concept of conditional probability, and by the estimation of maximum likelihood, it is able to calculate which word will occur in that particular place. I hope you understood. Okay. Now you come for what is conditional probability. Okay. So conditional probability formula everybody knows. Okay. The probability of occurrence of word B if the word A is given. I am talking in the context of our natural language processing. Okay, is equal to probability of A and B, the words A and B, divided by the probability of word A is given. Okay, I can able to rewrite this formula P of A comma B equal to, so I am taking this towards this side. So what is this one? P of B given A into P of A. I hope you understood. Okay. So this is the conditional probability formula. I am just rewriting the formula. Okay. Now this is the probability of occurrence of words A comma B equal to probability of B given word is A dot P of A. Okay. Now here only two words are there or two variables are there. But in a sentence, if you see, take the sentence, multiple words are there. Okay. Suppose for example, four words are there, A comma, B comma, C comma, D. Then how will you write? Okay. So first one is the independent variable P of A. Then what about P of B? P of B is taken from the word A. Okay. Then what about P of C? P of C, the occurrence of P of C depends or related to the words A and B. Similarly, what about P of D? The occurrence of word D relates to the word A, B and C. Okay. So what about this rule? Are you able to relate anything? So this rule we are calling it as chain rule. This rule we are calling it as chain rule. Okay. So once again I will repeat for your understanding purpose. Okay. So how N-gram model is going to achieve the task of finding the word, perfect word or the maximum probable word that will suit for that particular place in the sentence. Okay. So how it is going to find it out? Okay. So the thing is, it will use the concept of conditional probability by using the chain rule concept, okay, and by calculating using the formula of maximum likelihood, it will find out the particular word or character for that particular sentence. Okay, that's why first we have started discussing about the conditional probability formula. Okay, what is conditional probability formula? Probability of occurrence of the variable B if the variable A is given is equal to probability of, or we can able to say joint probability of variable A and B divided by probability of variable A. This is the conditional probability formula. I am rewriting that particular conditional probability formula. Okay, so I am bringing this one towards the left side. Okay, so it becomes, so the formula becomes probability of occurrence of A and B. Okay, it relates to this particular formula. It is for two variable. Okay, so how about it's for four variable? How about it's for five variable? Okay, so it used the concept of chain rule. It used the concept of chain rule. Okay, so this is how N-gram is able to analyze and identify which word will occur best in that particular place of that sentence. Okay. Now, how we can write as common one? Okay. So I can write it as a general one. So instead of A, B, C, D, I am writing probability of occurrence of word 1, word 2, word 3, word 4 equal to, okay, so probability of word 1, because there is no previous word, okay, it is an independent word, okay, then probability of word 2 is followed by the word 1. Okay, so that is the meaning of this. Okay, similarly, word 3, the occurrence of word 3 if word 1 and word 2 is given. Okay, similarly, probability of word 4, the occurrence of probability of VAD 4 is related to is VAD 1, VAD 2, VAD 3 is given. Okay. Now how we will write as a general case. So here everything is dot product. Okay, giving it as phi 1. Probability of W of I represents W1, W2 up to Wi minus 1. Okay, probability of okay. So why we are seeing these mathematical steps and formulas? So these are all the steps the n-gram will follow to identify, okay, so which word will occur as a most probable way. Okay, so that will be identified through these particular steps. Okay, I hope you understood this one. Now I am okay. So here, okay, so there are several types of n-grams are there. Okay, so this is what we have discussed till now. Okay, so the chain rule we already discussed. Okay, there are n number of words. How we can find the occurrence, probability of occurrence. Okay, so first we will write it as an individual one, step by step. Okay, so these steps we are calling it as chain rule. Okay, now from the chain rule we are writing the common formula. Okay. Okay. So now there are several types of n-grams, depends upon the number of words used for analyzing. Okay. So first one is unigram. Okay. So one minute. So we can write types of n-gram. Okay. So it starts from unigram. Okay. So what is unigram? We can also say it as 1 gram. Okay. So second one is bigram. Okay. In short, we used to call it as 2 gram. Okay. And here, and one word history is used. We will see what it means. Okay. And third one is trigram. Trigram. What is trigram? In short, we used to call it as 3 gram. Okay. Here, history, 2 word history is used to analyze that particular word. Okay. Similarly, it will go on 4 gram, 5 gram, 4 gram. Okay. So how many word history is used? 3 word. History is used. Okay. Similarly, it will go on 5 gram. It will go on. It will go up to n gram. Okay. Okay. So once again I repeat. So there are several categories in n-gram. It's starting from unigram. It is also called as 1 gram. Okay. Second one is bigram. It is also called as 2 gram because, so why we are calling it as bigram means, so in the sentence, okay, for example, okay, so I am giving one example. Okay, we will see that one. Okay. So about 5 minutes from. So about 5 minutes from. So I have to find out what is the word will occur in this particular place using bigram. Okay. So how bigram will work? It will take the previous single word. Okay. So for example, for bigram, one word history. Okay. So it will take the previous word. Okay. And it will check in the corpus. So in the corpus, after we have mentioned the sentence about 5 minutes from dash. So the expectation is you have to fill the place with a suitable word dash. Okay. So how the model will able to check the history from the corpus. Okay. So if I am using bigram model, it will choose how many word history? One previous word. Okay. So what is the previous word? It is from. Okay. Now it will go to the corpus, that is the dictionary or the history. Okay. So how many words comes after the word from? The number of occurrences it will check, out of which one is the maximum, it will choose that one and it will fill in this place. Okay. Similarly, if you talk about trigram, okay, so how many words are taken for the history? 2 words. Okay. Now, if I am adopting, so if I am applying trigram here, okay, so how it will work? Okay, so about 5 minutes from dash. So this is the expected place word has to be filled. Okay, so how many previous words it will be taken? 2 previous words it will be taken, minutes from. So it will check the corpus. So how many times, okay, after minutes from the word, minutes from the word is coming number of times. Okay, that word it will choose and it will fill here. Anyhow, we will see practical example so that you will understand very better. Okay. Now next one. Okay. So we have discussed about, okay. So once again I recollect. So we have discussed about what is language model and what is n-gram model. So why language model is required? Okay. So how language model is going to predict the word or a letter from the sentence? Okay, or for the sentence. Okay. So that's why we have discussed about the concept of conditional probability and chain rule. Okay. And one more formula is also there to estimate which word will occur in the most occurrence. Okay. For that, one more concept is there, that is maximum likelihood. Okay, so using this, it can able to find out, okay, so which one will occur better. Okay, for example, okay, if you take bigram example, okay, probability of occurrence of word I, if the word I minus 1 is given, the previous word is given. So from that, okay, what is the formula to find? Count, okay, so occurrence of word I minus 1 and word I divided by count occurrence of word I minus 1. Okay. So this is how, okay, so model, n-gram model is able to analyze which word will best suit for that particular place to fill. Okay, I hope you understand. Okay, so we have discussed 3 steps. Okay, so first one is conditional probability. Okay, then using the conditional probability, then we applied for multiple sentences, we applied the chain rule. Okay, and by using the formula of maximum likelihood, the n-gram model or bigram model or trigram model is able to find out which word will best suit in that particular position where it required. Okay, so I hope you understood. Okay, so we will see that example. Okay, how to write that one. Okay, the same example I am taking. So about 5 minutes from. So probability. So how to write this one? Probability of occurrence of about 5 minutes from. So how to rewrite this one? Okay, so we have to apply the chain rule. We studied previously, right? So what is chain rule? Okay, so this is the chain rule. So this is the chain rule. Okay, so I am going to apply the same concept for this particular sentence. Okay, so first word, okay, that is the independent word, P of about. Okay, second one into probability of 5, occurrence of the word 5 if the word about is given. we have to check this probability in the corpus. Okay, similarly, okay, next one. Okay, so next one, what is the next word? Minutes. So I am writing here for better understanding. So probability of occurrence of minutes, okay, if the previous word about 5 is given, then from, I am writing here, probability of occurrence of the word from if the previous word about 5 minutes is given. This is how we will apply the chain rule, and from that we will go on together and we will find out the estimation like that. Okay. Now we will see one by one in detail. Okay. So this is a general one. I hope you understood, right? So how to split and write using the chain rule. I hope you understand. So this is the sentence given. Okay. So in this sentence, okay, using the chain rule, I am splitting and writing into several probabilities. Okay. This I hope everybody understood in a better way. Okay. Now we will see how we can find out using the bigram model. Okay. So how we can find out, uh, substitute and find out using the bigram model just as an overall view. Okay. So I am not going to see here. Okay. So first of all, okay, we will see unigram model. Okay, when we talk about unigram model, okay, there is no history will be used. Okay, so this is the concept of unigram. So it won't, because it is a single word. It is a single word. It won't take any history previous word. Okay, so in that case, so how it will predict? So it will check the corpus which word the probability of occurrence is more. Okay, so it will take that particular word and fit it. Okay, so this is the concept of unigram model or one gram model. Once again I repeat. Okay, so I am taking the word, I am taking the sentence, okay, about 5 minutes from. Now the expectation is I have to find the word which is the word best suit here. Okay, so I am going to use the first concept, that is unigram model. Okay, so unigram model, what is the concept? It won't use any history. Okay, now what it will do? So it will check the corpus. Okay, so which word is having the highest probability of occurrence? It will take the word and fill it here. But sometimes it will not match properly. Most of the times it will not match properly. Okay, so that is the disadvantages of going for unigram model, because it won't go for the previous word. Okay, so I hope you understood. Okay, so we have discussed about the first one of types of model, language model, that is the unigram model. Okay, so it is shortly noted as 1 gram model, and also keep it in a mind, no history is used in this unigram model. Okay, how it will work? So in the corpus or in the collection of text, okay, that will be called as corpus. Okay, so here it will find out which word the number of occurrence is more, it will choose that word and it will fit here. Okay, but number of times it will not be the perfect match. Okay, so this is what about the unigram or 1 gram model. Okay, next one is bigram or 2 gram model. Okay, so already we have discussed about how to write maximum likelihood estimate for bigram model, right? Okay, Yeah, sorry, 1 minute. Okay, so now we are going to see the same sentence. Okay, so how we are going to assume using bigram model. For an example, we are taking two assumptions. The next word, the place where it may be college or class. Okay, for an understanding purpose. Okay, now how it will be applied in a formula and how it will find out in a bigram model. This is what we are going to discuss now. Okay, as we already discussed, okay, the probability of finding the word two. So while we are giving using this will become 2, right? Because only 2 bigrams. Okay, product of W2 word 2 if W1 is given. This is the general formula is rewritten into towards bigram approach. Okay, so now, okay, so how will you write it in the maximum likelihood formula? Okay, count. Okay, count. Okay, so what it has to do here, W1 comma W2. So count of occurrence of both words together. Okay, that is the meaning of this one. What is the denominator side? Count of word 1 alone. That is the previous word, history word alone. What is bigram approach? It is a 2 gram model. Okay, history, how many words it will take? Only one word it will take. One word means the previous word. For example, okay, the sentence is about 5 minutes from. So the expectation is we have to find a suitable word here. Okay, so if I am using bigram model, okay, so what is the previous word? From. It will take one history, one word history. That means it will take previous one word, then it will check the corpus. So for that word from next, okay, how many words are occurring? How many different words are occurring? Out of that, which word the occurrence is probability of occurrence is higher, that word it will take and it will fill here. For example, college and class. Okay, this is an assumption. Okay, for an example, there are two words are occurring after from. From class, okay, from college in the corpus. Okay, so this occurred 4 times. This occurred some 6 times. So bigram model will choose this one. Okay, so it will fill here from college. I hope you understood. This is how these language models used to work. Okay, so anyhow, first we will see how we can write the formulas. Okay, so that in the later case it will be easy for everyone to do the problem in a better understandable manner. Okay, so this is a maximum likelihood formula, everybody knows. So it is written based on the bigram approach. Okay, if suppose trigram means here 3 words will come, W1, W2, W3. Okay, likewise. Okay, I will explain. Okay, so probability of, okay, I am taking for this example, okay, about 5 minutes from. Okay, so how to split using the chain rule? Okay, or otherwise we can write in general as count. Okay. So now there are two expectations. One is college, another one is class. Okay. So now I am writing probability of occurrence of the word college if, okay, the sentence is given about 5 minutes from. For this, write a formula. Okay, understood? Now once again I repeat. Okay, so we are seeing bigram approach. Okay, unigram approach we already discussed. Now we are seeing bigram approach. So bigram approach, it will use one word history. That means one previous word it will use for finding the better word. Okay. So here for understanding purpose, we are assuming that the next word may be college or class. Two possibilities are there. Now we will see how we can substitute in a formula, maximum likelihood formula. Okay. So how it will change? So count. So how will you write? About 5 minutes from. It's from college divided by denominator. How will you write? About 5 minutes from. So I hope you understood. So this is the general formula I have written previously. Once again I will write. So W2 W1 P equal to count of W1 comma W2 divided by count of W1. Okay, what is the meaning of this? Probability of occurrence of word W2 if word 1 is given equal to count of, okay, word 1 and word 2 together. Okay, count of word 1 alone. Okay, now you bring it here. Okay, what is W2? It is college. What is word 1? In that place there is one sentence is there about 5 minutes from. Okay, come to the right side. Count of W1 comma W2 together. What is W1? About 5 minutes from. I am writing here about 5 minutes from. What is W2? W2 is a college. So I am writing here. Okay, count of about 5 minutes from college. Okay, what about denominator? Count W1. What is W1 here? About 5 minutes from. I am writing here about 5 minutes from. Okay. So now you take the numerator part alone. Okay. For easy understanding, I am taking the numerator part alone and split into individual one using chain rule. Okay. We have studied first conditional probability, then we have discussed about chain rule, then only we have discussed about maximum likelihood estimation. Okay. So don't forget these three steps. Okay. So whenever we are talking about n-gram model, these three steps are very, very important. Okay. So now how will you write? So this can be rewritten as, okay, so probability of about, okay, into P of 5 by about into P of minutes given 5. Why I am writing only one word? So the question may arise for you, because first one is okay. I am splitting the entire numerator part. Okay, that is what I am doing now. Okay, entire numerator part. Okay, so about is the first word in that sentence. Okay, So it is an independent one. I am writing, okay, individual. Okay, second one, if you see here, 5. 5 is the word, the occurrence of the word 5 if the word about is given. That is what I mentioned here. It is also fine. What about here? I am writing the next one. If minute is the word, occurrence of minutes if the previous word is 5. I am not taking about. Why? Because I am using the concept of bigram. Bigram, previous history, it will take only one word. Okay, I hope you understood. That's why I am taking individual word. Similarly, next one, from. Probability of from, what is the previous word? Minutes. Okay, similarly, probability of occurrence of college, what is the previous word? From. Okay, now the numerator part is over. I have splitted everything using chain rule. Okay, now denominator part. Come to denominator part. Okay, write the same using chain rule. Okay, probability of, about. Okay, similarly, what is the next one? 5, probability of, mentioned with about. Similarly, next one, probability of minutes, next with 5. Next one, probability of from, previous one, that is minutes. Okay, I have splitted the denominator also. Okay, so I hope you understood. I have splitted the denominator and numerator. Okay, now if you check probability of about, probability of occurrence of the word about, the number, okay, what we are getting is same for this one also. So it will go. Similarly, this will go. Similarly, this will go. This will go. So what is remaining? So probability of college. Okay. Once again I repeat. Okay. So there are two expectations in this sentence. About 5 minutes from, after that there may be a word college or there may be a word class. Okay. So their expectation is two words. Okay. So using bigram, we have to identify which word will best suit for that. Okay. So first step, what I am doing, I am writing using math. I am writing the formula of maximum likelihood estimation. Okay. So I am writing here. Okay. So this is the formula for that. Okay. So I am taking the first word, college. If the occurrence of college using that given word, I am finding out the maximum likelihood. Okay, so how to find out? I am substituting in a formula. So count, okay, so W2 comma W1. Okay, so similarly I am substituting in a maximum likelihood formula, and then I am splitting that numerator and denominator using the chain rule. Okay, so we very well know. Okay, and after that the common probability terms we are discarding. Okay, because numerator also probability of about is there, the same number will be there. Denominator also probability of about same number will be there. So I am dividing it, discarding it. Okay, similarly all other terms will be discarded. Okay, so finally, okay, which one is remaining? P of college from. What it means? Okay, the probability of occurrence of the word college if the word given from. That means instead of analyzing all the sentences, okay, so it is better to analyze, okay, the word based on the previous word alone. Okay, So this is what the meaning of this particular formula and functions. Okay, I hope. Similarly, if you substitute in the place of class and substitute in the maximum likelihood formula, you will get the same mean. So probability of class given word is from. Likewise, you will get. Okay. So the bigram model will identify the probability of occurrence of the word class from the previous word from in the corpus. Okay. So this is what the meaning of these particular steps. Okay. So similarly, now if you see this PPT, you can able to understand what it means. So bigram, in short, we are calling it as 2-gram. Okay. It use one word history. That means if suppose it wants to find a word, it use the previous word alone. Okay. That is one word history. Okay. So here it will substitute in the maximum likelihood estimation formula and split using the chain rule, and then we can able to find it out. Okay. So this is how it will able to do that. So this is what explained here. So take the numerator and split it using the chain rule, and similarly here split it using the chain rule. So finally find it out. See here, for this one this is the answer, for this one this is the answer. Okay. Next one is a trigram approach. Sorry, 1 minute. Okay. So till now we have discussed about two types of language model. One is starting from unigram, that is also called as 1-gram. In that no history is used. Okay. So these are all the basic things we have to keep it in our mind. Okay. Next we have discussed about bigram model. So bigram model, in short we are calling it as 2-gram model. Okay. So here one word history is used. Okay. That is previous word, it plays a major role in finding out the expected word. Okay. So now we are going to see about the next one, that is trigram model. Okay. So here, okay, 2-word history is used. Okay. So 2-word history is used. Okay. Okay, sorry, it is a 3. Okay. So 2-word history is used. So 2 words history is used, and if you substitute in that maximum likelihood formula, okay, so how we will write in general? So W of I, if I want to find it out, okay, so what are all the previous words I need to check? W of I minus 1, W of I minus 2. Okay. So how I write in the maximum likelihood formula? So count of, okay. So W of I minus 2, comma W of I minus 1, comma W of I. Everything we have to write together in the numerator. Okay. So denominator, so count of that 2 previous words alone you have to write it. Okay. So this is what the formula for finding the maximum occurrence of word using the trigram approach. Okay. So using the trigram approach. So we take the same formula, sorry, same example, about 5 minutes from. Okay, so there are two expectations, same, college or class. We have to find it out using the trigram model. Substitute in that formula. Okay, see here. Okay, so first this is the denominator side they have done. Okay, and this is the numerator they have calculated and substituted here, and this is the result. Okay, for time being, so I am not deriving here. Okay, so in your free time you just practice it. Okay, so instead of single word from the previous word, that means in bigram model we have used single words. So in trigram models we have used two words. Okay, see here, two words. So that is the difference. Okay, see here, every probability they used to take from two words, two previous words. Okay, so that is the difference between bigram and trigram. Okay, so see here, every word. Okay, the probability of occurrence of the word 5 if two previous words are given. So that is the meaning of this sentence. Okay, similarly, the probability of occurrence of word minutes if two previous words about and 5 is given. Okay, so similarly, if you substitute numerator and denominator, the common terms will get discarded. Okay, so finally, we will find out probability of college from the previous two words minutes from. Okay, so for your understanding purpose, I will. Okay, so this is the example about 5 minutes from dash. So here we have to find the suitable word using trigram. Okay, so trigram, what is the concept? It uses previous two words. So from previous two words history, it will check. Okay, so which word is coming several times, the number of occurrence is more, so it will choose that particular word and it will substitute here. Okay, so this is the concept of trigram. Okay, similarly, next one, 4 grams. Okay, next one is 4 grams. So in 4 grams, how many previous words it will use? It will use 3 words it will use. Okay, so that is the thing. Okay, in short, it is called as 4 gram. Okay, 3 words history is used. Okay, so that is the meaning of that. Okay, again substitute in that maximum likelihood formula, and based on that we can able to find the result. Okay, so if you see the result, okay, see here. So probability of finding the occurrence of the word college if the previous words 5 minutes from. Okay, so it will find out from the previous 3 words. Okay, so that is the meaning of this one, and it will go on. Okay, and it will go on. Next 5 gram, how many previous words it will take? 4 previous words it will take. If I am using 6 gram, okay, how many previous words it will take? 5 previous words it will take. So it will go on. But the thing is, okay, so as the number of previous states increases, okay, it is very difficult to match the particular word in corpus. Okay, anyhow, we will see in that example so that we'll understand better. Okay, so if it is one word or two words, it is very easy to find the number of occurrence of the expected word. We can able to easily find it out. But when the number of history, that means here actually 3 words we are taking, previous words, right? Suppose if you are going for 4 words, 5 words, okay, it is very difficult to match it, and also very difficult to find that common occurrence in that particular sentence. Okay, so that is what is there. Okay, so the probabilities of larger collection of word is minimum. To overcome this problem, mostly people will go for bigram model. Okay, so this is what the case. Okay, so next one. Okay, so this evaluation we'll see. Okay, so today once again I will repeat. So we have discussed about the types of n-gram model. Okay, so in this session we have started discussing about, so what is n-gram model, what is language model. Okay, so why we are going for language model, so where it is required, and then we have started discussing about n-gram model and its types. Okay, starting from unigram model. So what is unigram model? It is a 1-gram model. No history is used in that case. Okay, it is not that much accurate. Okay. Then we have discussed about 2-gram model, that is bigram model. Okay, so bigram model we have discussed. Okay, in that it is also called as 2-gram model in short. Okay, and here one word history is used. Okay, that means one previous word is used to find the which word is suit in that particular position. Similarly, next trigram we have discussed, and 4-gram also we have discussed, and it will go on. Okay, but it is not good if you increase the number of words in the history. So the complexity will be more to find the best match. Okay, so this is what we have discussed in the types of n-gram model. Okay, and then we have also discussed about how n-gram model is used to find out the best word in that particular position of that sentence. Okay, so how it is able to find out? So using the concept of conditional probability and using the chain rule, and by using the maximum likelihood estimation, it able to find out, okay, so which word will occur best in that particular position. Okay, this is what we have discussed so far. Okay, so next session we will discuss about case studies, smoothing approach, and perplexity. So we will see some practical problems so that it will be very easy for you to understand the concept in more better way. Okay, so today's session we have discussed about the concepts, so why it is used for and how it is used, and what are all the mathematical formulas behind it we have discussed, and all these things we have discussed. Okay, so next class we will discuss with one practical case study, so that we will able to understand so how this interprets in a better way. Okay, there are two evaluation scenarios. So one is extrinsic evaluation, next one is intrinsic evaluation. Okay, so what is mean by extrinsic evaluation? So it evaluates the language model while solving a specific task. For example, okay, so I want to find out the speech recognition accuracy. Okay, or otherwise I am doing some machine translation from Google to somewhere, or okay, in that case, so I want to check the accuracy of that. So in that specific task, so if I evaluate the language model, this kind of evaluation we are calling it as extrinsic evaluation. Okay, but the major drawback is it is highly expensive and also time consuming. Okay, there are two ways, different criteria for evaluation of language model, whether it is working perfectly or not. One is extrinsic evaluation, next one is intrinsic evaluation. Okay, extrinsic evaluation is when we are evaluating the model while it is doing some specific task. Okay, any one specific application while it is running, if you test that particular case or if you evaluate that particular model, such evaluation we are calling it as extrinsic evaluation. Okay, but the major drawback or not drawback, major disadvantage is, okay, so it is highly expensive and also time consuming is very high. On the other hand, okay, intrinsic evaluation. Okay, so the language model is best when it predicts an unseen test set. Okay, so this kind of evaluation we are calling it as intrinsic evaluation. Okay, so in next class we will discuss about the concept of perplexity so that we will understand better. So I am not touching now. Okay, just understand that. So today we have discussed about language models. Okay, so what is mean by language model and why we are using language model. So what are all the major applications we have used language models we have discussed, and after that how we can evaluate the language models. Okay, there are two different sets of evaluation. One is extrinsic evaluation, next one is intrinsic evaluation. Okay, so thank you so much. We will see in the next session.